Okay. Hi, everyone. In this section, we'll be talking about the SPSS method for test about means. We'll be going through two tests. One is t-test for one mean, and the other test will be t-test for two independent means. These are the ones that we have discussed in the material of this week. Okay, so first of all, we want to talk about t-test for one sample mean. Okay. To conduct a t-test for one mean in SPSS, you'll be going through these following steps: analyze, compare means, and one sample t-test, which means if you have only one sample from a population and you are comparing this mean with a specific amount, we go one sample t-test. Okay, and choose the variable and enter the hypothesis value in the test value box and click OK. We'll illustrate this by using this example. Is the mean body temperature really 98.6 degrees Fahrenheit? Okay, so we are using a data set 3 body temperatures that includes the measured body temperature from 12 a.m. on day 2 with these statistics. N equals 106, so 106 temperature were taken in the sample with the sample mean 98.2. Sample standard deviation 0.62. And we're trying to test a claim that at 0.05 significance level, that the common belief that population mean temperature will be 98.6 degrees Fahrenheit. Okay. Hypothesis is going to be our first step, step 1 hypothesis. So we're trying to test a claim that the population mean temperature is 98.6. So mu would be 98.6, and therefore alternative will just be mu is different from 98.6 because it doesn't specify whether the population mean temperature is less than or greater than. So in general, this will be greater than 98.6. And this will be a two-tailed test because of this not equal sign. Okay, so over next, we'll be trying to figure out the test statistics and p-value. And what we need to do is go back to the SPSS in your virtual desktop. And over here, I have pulled up to the data file, and that is the day 2 at 12 a.m. temperature. Okay, day 2, 12 a.m. temperature. We go analyze, compare means, and this is only one sample, right? So we just go one sample t-test. Okay, we're comparing this day 2, 12 a.m. temperature. So this is the test value variable. Compare that with 98.6. So 98.6 will be your test value, 98.6. Enter that manually. Hit OK. Therefore, we'll be getting these two output tables. One gives you the sample statistics. For the temperature at day 2, 12 a.m., the mean is 198.2, sample size is 106, standard deviation is this given. And then the second table is one sample t-test. And be careful when you are doing this. You're going to make sure you have the test value specified over there, 98.6. Okay? And you'll be given with the t, test statistic with degrees of freedom. And this will be the p-value. These 3 items are the ones that you need to record. Okay, so let's continue. All right, so we copy and paste these two, and let's try to get our conclusion over here. So we're going to do the t and the p. And once again, I want to emphasize, make sure your test value is 98.6, as you see in this 98.6 in the hypothesis. So we can say test statistic t is negative 6.611, whose p-value is 0. This is two-tailed test. We just copy this p-value right away. So the decision rule will be reject null hypothesis if p-value is less than the 0.05. And our current p-value is 0. So it is indeed less than 0.05. So reject null hypothesis. And meaning we're going to accept alternative, right? Reject null is the same as accept alternative. There is sufficient evidence evidence to conclude that the population mean temperature is not 98.6 degree. Mu is different, 98.6 degree. P-value will be 0. Okay, so this is one sample t-test comparing the population mean, okay, with certain value, one sample. Now, if we revisit the question and suppose you want to test a belief that population mean temperature is less than 98.6, how's that going to change our question? One thing we need to change is you're going to change the alternative hypothesis to less than 98 according to the claim. And this will turn to a one-tailed test. One-tailed test will basically affect the p-value because this value is from two-tailed test p. You're going to divide this p-value by 2. That will give you still 0. It's not going to affect our decision because the alpha is the same and the p-value will still be less than the alpha. So reject null hypothesis. So reject null hypothesis and accept alternative. There is sufficient evidence to conclude that the population mean temperature is now less than 98.6 degrees Fahrenheit. Okay, that matches the alternative hypothesis we are accepting. Okay. All right, the second test we want to introduce is two sample t-test. This is worked when it comes to getting two samples and you compare those two samples with their mean. The general steps are go analyze, compare means, and choose independent samples t-test, and move the numeric values into the test value, and move the one variable for you to put into groups as grouping variable. Grouping variable needs to be defined, and define the groups and enter the values of grouping variable, often 0, 1, or 1 and 2, depending on what it shows up in your hypothesis. We'll illustrate this by using the next example. So the next example is, at 0.05 level of significance, test a claim that the mean attention span for teenager males and females are different. So here we have two groups, right? You're comparing teenager males with teenager females regarding their mean average attention span. Okay, so first of all, let's go ahead and define the two groups. Group 1, teenager male. Group 2, teenage female. Hypothesis will be, first of all, they have the same mean attention span. Alternative, according to our hypothesis, they are assuming different, trying to claim different attention spans. So alternative will be mu1 different from mu2. This is a two-tailed test. All right, and then we're going to carry out the test in SPSS. Let's go ahead and go back to the SPSS. All right, so here is the original data with attention span and based on gender. Okay. The attention span based on the gender, whether it's female or male for the teenager. Now it's worth noting for the gender, 1 is for the male, which is the first group, and 2 is female, which is the group 2. Okay. So when we are compare their means on attention span, we go analyze, compare means. These are two independent samples, so independent samples t-test. We're testing on their attention span, so choose that attention span in minutes as the test variable. Grouping variable is based on the gender. So you're going to move the gender of the participant into the grouping variable. At the same time, you got to define the groups. Okay, the groups are defined as 1 is male, group 2 is female. For male, its value in gender is 1. For female, its value in gender is 2. So 1 and 2, continue, hit OK. And this will give you the two output chart. We can tell there are 22 males in the sample with their attention span average is 6.2955, and female attention span will be 9 minutes, right? And this is the table including the test statistics. Okay, so we just copy and paste this two tables. Continue over here. So these are the two tables listing statistics and also the test statistics. Again, for the independent sample t-test, if you look at this table here, we should be only focusing on t and degrees of freedom, and you'll be looking at not assuming equal variances for the male and female groups, okay? Because we don't know the population standard deviation, so we don't assume have equal variance for those two groups. So make sure you go the second row, okay, and record these test statistic t and as well as the p-value. Okay, so over here I've put the information p-value for a two-tailed test. Be sure to use the equal variances, not assume the row. This is the row number 2. Don't use the row number 1. Second row, not assuming equal variances. Okay, so therefore we can carry out this test. So null and alternative has been specified. Test statistic will be this negative 2.429, which is from the second row, and p-value will be 0.02, which is again from the second row. And this is already a two-tailed test, so there's no need for you to divide the p-value by 2 or not. Okay, just write down 0.02. Rejection rule, reject null hypothesis if p-value is less than 0.05, and our p-value is 0.02, which is less than 0.05. Therefore, we should reject null hypothesis, which means accept alternative. There's sufficient evidence to conclude that mean attention span for teenager males and teenager females differ. They are different, right? They have different attention span. Also, you can get the D, the effective size. Okay, effective size can be carried out by using the formula, which is the difference of the sample means and divide by the smaller standard, the bigger standard deviation. So 0.7424, this is a large effect. So that means the gender does play a big role in terms of the attention span. Okay, so that's all that we have for the t-test for samples. There's one sample t-test and two independent samples t-test.